Ocean current. Ocean surface currents. An ocean current is a continuous, directed movement of seawater generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, cabling, and temperature and salinity differences, depth contours, shoreline configurations, and interactions with other currents influence a current's direction and strength. Ocean currents are primarily horizontal water movements. An ocean current flows for great distances and together they create the global conveyor belt, which plays a dominant role in determining the climate of many of Earth's regions. More specifically, ocean currents influence the temperature of the regions through which they travel. For example, warm currents traveling along more temperate coasts increase the temperature of the area by warming the sea breezes that blow over them. Perhaps the most striking example is the Gulf Stream, which, together with its extension the North Atlantic Drift, makes Northwest Europe much more temperate for its high latitude than other areas at the same latitude. Another example is Lima, Peru, whose cooler subtropical climate contrasts with that of its surrounding tropical latitudes because of the Humboldt Current. Ocean currents are patterns of water movement that influence climate zones and weather patterns around the world. They are primarily driven by winds and by seawater density, although many other factors, including the shape and configuration of the ocean basin they flow through, influence them. The two basic types of currents, surface and deep water currents, help define the character and flow of ocean waters across the planet. Causes. The bathymetry of the Kerguelen Plateau in the Southern Ocean governs the course of the Kerguelen Deep Western Boundary Current, part of the global network of ocean currents. Ocean dynamics define and describe the motion of water within the oceans. Ocean temperature and motion fields can be separated into three distinct layers: mixed, surface, layer, upper ocean, above the thermocline, and deep ocean. Ocean currents are measured in units of Sverdrup, SV, where 1 SV is equivalent to a volume flow rate of 1 million cubic meters, 35 million cubic feet, per second. Surface ocean currents, in contrast to subsurface ocean currents, make up only 8% of all water in the ocean, are generally restricted to the upper 400 meters, 1,300 feet of ocean water, and are separated from lower regions by varying temperatures and salinity which affect the density of the water, which in turn defines each oceanic region. Because the movement of deep water in ocean basins is caused by density-driven forces in gravity, deep waters sink into deep ocean basins at high latitudes where the temperatures are cold enough to cause the density to increase. Surface currents are measured in units of meters per second, m/s, or in knots. Wind-driven circulation. Surface oceanic currents are driven by wind currents. The large-scale prevailing winds drive major persistent ocean currents, and seasonal or occasional winds drive currents of similar persistence to the winds that drive them, and the Coriolis effect plays a major role in their development. The Ekman spiral velocity distribution results in the currents flowing at an angle to the driving winds, and they develop typical clockwise spirals in the northern hemisphere and counterclockwise rotation in the southern hemisphere. In addition, the areas of surface ocean currents move somewhat with the seasons. This is most notable in equatorial currents. Deep ocean basins generally have a non-symmetric surface current, in that the eastern equator-ward flowing branch is broad and diffuse whereas the poleward flowing western boundary current is relatively narrow. Thermohaline circulation. Deep ocean currents are driven by density and temperature gradients. This thermohaline circulation is also known as the ocean's conveyor belt. These currents, sometimes called submarine rivers, flow deep below the surface of the ocean and are hidden from immediate detection. Where significant vertical movement of ocean currents is observed, this is known as upwelling and downwelling. An international program called Argo began researching deep ocean currents with a fleet of underwater robots in the 2000s. The thermohaline circulation is a part of the large-scale ocean circulation that is driven by global density gradients created by surface heat and freshwater fluxes. The adjective thermohaline derives from thermo referring to temperature and haline referring to salt content, factors which together determine the density of seawater. Wind-driven surface currents, such as the Gulf Stream, travel polewards from the equatorial Atlantic Ocean, cooling en route, and eventually sinking at high latitudes, forming North Atlantic deep water. This dense water then flows into the ocean basins. While the bulk of it upwells in the Southern Ocean, the oldest waters, with a transit time of around 1,000 years, upwell in the North Pacific. extensive mixing therefore takes place between the ocean basins, reducing differences between them and making the Earth's oceans a global system. On their journey, the water masses transport both energy, in the form of heat, and matter, solids, dissolved substances, and gases, around the globe. As such, the state of the circulation has a large impact on the climate of the Earth. The thermohaline circulation is sometimes called the ocean conveyor belt, the Great Ocean Conveyor, or the global conveyor belt. On occasion, it is imprecisely used to refer to the meridional overturning circulation, MOSI.